A swarm of 50,000 bees is hanging from a tree branch right now, and within 24 hours, every single one of them will cast a vote, count the results, and fly to their new home in perfect unanimous agreement. No CEO. No queen giving orders. No arguments. Just pure, flawless democracy that puts human politics to absolute shame. Fact number 1. Honeybees invented democracy at least 20 million years before humans did. The fossil record places honeybees, genus Apis, on Earth approximately 35 million years ago. The earliest recognizable human democratic systems, like those of ancient Athens, only emerged around 507 BCE. That is a gap of roughly 34.999 million years. And here is the jaw-dropping part: bee democracy is not a metaphor or a loose comparison. Cornell University entomologist Dr. Thomas Seeley, who literally wrote the book on this, his 2010 landmark text is called Swarm Intelligence, documented through decades of controlled field research that honeybee swarms conduct a formal, multi-round, consensus-based vote to select a new home. Every key feature of a functioning democracy is present: candidate nomination, campaigning, debate, vote counting, and a unanimous final decision. When you vote in your next election, just remember the bees were doing it before mammals even had teeth. Visual note: show animated timeline infographic, 35 million years ago marker for Apis fossils, 507 BCE marker for Athenian democracy, with a bee icon and a Greek column icon respectively. Fact number 2. Scout bees are professional debaters who literally headbutt each other to concede. When a honeybee colony outgrows its hive and a new swarm forms, a process called swarming, the colony dispatches roughly 3 to 5% of its population as scout bees. In a swarm of 10,000 bees, that is between 300 and 500 individuals simultaneously flying out in different directions to locate potential nest sites. Each scout independently evaluates a candidate site based on at least 12 measurable criteria documented by Seeley's team, including cavity volume, they prefer between 30 and 50 liters, entrance hole size, height above ground, and whether the entrance faces south to maximize solar warmth. When a scout finds a promising site, she returns to the swarm cluster and performs a waggle dance. The more enthusiastic the dance, measured in the duration of waggle runs, which correlates directly with site quality, the better the scout thinks her site is. But here is where it gets wild. When a bee disagrees with another bee's candidate, she performs what researchers call a stop signal. She headbutts the dancing bee and produces a short 380 Hz vibration burst that literally translates as, quote, "Stop what you are doing." It is the bee equivalent of standing up in a town hall meeting and shouting objection. This was documented in rigorous detail by Dr. Seeley and Patrick Kerwin in a 2012 paper published in the journal Science. Visual note: show a side-by-side diagram of a waggle dance path overlaid on a compass rose, and a second diagram showing the stop signal headbutt with vibration frequency labeled at 380 Hz. Fact number 3. Bees achieve 100% unanimous consensus, something human democracies almost never do. Here is the part that makes political scientists genuinely uncomfortable. In human democracies, a 51% majority is enough to make a nation-altering decision. Brexit passed with 51.9%. Roughly half a country disagreed. In bee democracy, that would be considered a catastrophic failure. Scout bees do not stop debating until one candidate nest site has attracted the support of approximately 15 to 20 bees performing waggle dances for the same location simultaneously, a threshold that represents something close to quorum. But critically, by the time the swarm lifts off to fly to its new home, the commitment is essentially unanimous. How? Because scouts who originally danced for losing sites gradually reduce the intensity of their dances, without any central authority telling them to do so. The quality of their own inspection memories simply fades in comparison as better options win more supporters. The losing side voluntarily stands down. Seeley described this in his 2003 paper in Behavioral Ecology as self-organized decision amplification. The colony reaches consensus the way a market reaches a price, through distributed, decentralized feedback loops, not top-down command. Visual note: show a bar chart animation where multiple colored bars representing different nest site candidates gradually shrink except one, which grows until it fills the entire chart, representing unanimous consensus. Fact number 4. The bees even have a built-in anti-corruption mechanism. Did you know that bee scouts cannot be bribed, promoted, or threatened? And this is not just a charming observation, it is a structural feature of the system with serious implications for political science. In 2011, researchers at the University of Sydney, including Dr. Madeline Beekman, published findings showing that a scout bee's dance enthusiasm is physiologically self-limiting. As time passes after a site inspection, the bee's neural encoding of the memory literally degrades, meaning she dances less enthusiastically for the same site the next day compared to the day she first discovered it. This creates a built-in expiration date on any individual bee's political influence. There is no way for a scout to maintain disproportionate influence over time. Compare this to human political systems where incumbency advantage in U.S. House races historically results in re-election rates above 90%. In bee democracy, the equivalent of a career politician is biologically impossible. Every scout's influence automatically decays unless new scouts independently verify and endorse the same site, creating a mandatory peer review process baked directly into the voting system. Visual note: show a dual infographic. Left side shows a graph of bee dance enthusiasm declining over 72 hours. Right side shows U.S. congressional incumbency re-election rate bar at 90% +4 contrast. Fact number 5. Bee swarms can make better decisions than groups of human experts, and this was tested. This is where the science stops being cute animal trivia and starts being genuinely mind-altering. In 2009, Dr. Thomas Seeley and his colleagues designed an experiment to directly compare bee decision-making quality against human group decision-making. They presented both a swarm of bees and groups of human subjects with the same type of multi-option choice problem, selecting the best option from several candidates of varying quality. The bees, using their distributed waggle dance system, selected the highest quality option more reliably and with fewer errors than human groups using conventional discussion-based methods. Seeley published analysis of this comparison in his book Honeybee Democracy, and it has since been cited in organizational management literature. NASA has formally studied swarm intelligence models, including bee-based algorithms, for application to autonomous spacecraft navigation. The European Space Agency's 2019 technical report on distributed satellite constellation management explicitly references honeybee quorum sensing as a design inspiration. When space agencies are copying your decision-making process, you are doing something right. Visual note: show a side-by-side comparison chart, bee group decision accuracy versus human group decision accuracy across multiple simulated trials, with bee column consistently higher. Display NASA and ESA logos alongside bee diagram. Fact number 6. The queen bee has absolutely zero say in where the colony moves, she is carried along like luggage. Everything you think you know about the queen bee running the hive is backwards. During swarming, the colony's most consequential democratic moment, the queen is completely passive. She does not scout. She does not vote. She does not even know where the swarm is going until she gets there. Scout bees make the entire decision autonomously. When the quorum threshold is reached, a subset of scouts performs a behavior called buzz running. They sprint through the swarm cluster vibrating their bodies at 500 Hz, which serves as a launch signal. The queen, who is located somewhere in the middle of that cluster, simply gets swept along with the mass flight. Dr. Seeley confirmed through queen tracking experiments at his Appledore Island Field Station in Maine that the queen's body position in the swarm cluster has no measurable correlation with flight direction. She is, in the most literal scientific sense, a passenger. She does not steer. She is steered. The colony's reproductive power lives in the queen's body, but executive decision-making power lives entirely in the distributed intelligence of the workers. It is the clearest example in all of biology of a system where the nominal head of state has no actual governing authority. Visual note: show an animated diagram of a swarm cluster as an oval mass, with the queen marked in a contrasting color in the center, surrounded by worker bees. Arrows show workers driving cluster direction while queen marker remains static. Fact number 7. Bee democracy has already been used to design real-world human technology. This is not theoretical inspiration. Bee swarm intelligence has been directly reverse-engineered into working algorithms already deployed in technology you probably use every day. In 2005, Computer scientist Eric Bonobo at the Santa Fe Institute, working from models of honeybee foraging and quorum sensing, helped develop what is now called the bee algorithm, a mathematical optimization framework. Telecom giants including British Telecom and Vodafone implemented bee-inspired routing algorithms in their network infrastructure to dynamically reroute data traffic, the same way scout bees dynamically reroute colony resources toward the best food sources. In 2017, MIT's Computer Science and Artificial Intelligence Laboratory published a paper demonstrating that a bee-inspired consensus algorithm allowed a fleet of 50 autonomous robots to reach coordinated collective decisions 30% faster than robots using traditional centralized command structures. That is not a metaphor. An actual engineering team at MIT built robot swarms that outperform conventional designs because engineers copied the math of honeybee democracy. The bees have been unknowingly filing royalty-free patents for 35 million years. Visual note: show a split-screen infographic. Left side is a stylized honeycomb network diagram labeled bee waggle dance routing. Right side is a data network routing diagram labeled BT/Vodafone network algorithm with visual similarity highlighted by matching color lines. Fact number 8. A single honeybee colony collectively evaluates up to 50 different nest sites simultaneously, and never chooses badly. Save the most staggering number for last. Dr. Seeley's 30 years of documented field research at Cornell University and Appledore Island, compiled across multiple peer-reviewed publications including a definitive 2012 science paper, established that a single honeybee swarm can simultaneously send scouts to evaluate up to 50 different candidate nest sites within a search radius of roughly 5 kilometers, which covers an area of approximately 78 square kilometers. Every one of those scouts independently measures the 12 quality criteria, encodes the results in neural memory, returns to the cluster, and contributes her data point to the collective vote via waggle dance. The swarm is, in effect, running a massively parallel processing operation, 50 simultaneous site surveys, all feeding data into one decentralized algorithm. And here is the kicker: in all of Seeley's documented observations across thousands of swarming events, a honeybee swarm has never, not once, made a fatal housing choice. Their error rate in selecting a survivable nest site is, for practical purposes, 0%. Human urban planning committees, operating with professional engineers, GIS mapping software, and million-dollar budgets, routinely approve building sites that later prove structurally or environmentally problematic. The bees, with no tools, no maps, and no budget, are batting a perfect game. Visual note: show a top-down map infographic of a 5 km radius circle containing 50 numbered location pins, each representing a candidate nest site. Animate a single golden pin illuminating as the unanimous winner while the others fade. Label the radius and area measurements clearly. So here is what we just established. Honeybees invented democracy 35 million years before humans. Their scouts campaign, debate, and headbutt each other into conceding. They achieve unanimous consensus without a single authority figure. Their system has a built-in anti-corruption mechanism that human politics cannot match. They outperform human experts at group decision-making. Their queen is literally just cargo. Their voting algorithm is now running inside the networks of major global telecoms. And they process up to 50 candidates simultaneously with a documented error rate of essentially 0. The next time someone tells you insects are simple creatures, you can tell them that the most sophisticated democratic system ever documented on this planet was designed by an animal with a brain the size of a sesame seed, and it has been working flawlessly since before the dinosaurs went extinct. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.